Hello students, welcome to the class. Our topic today is marine habitats under the branch of biology known as marine biology. In this class, we'll be taking it from where we stopped the other time, where I introduced to you aquatic habitat as a body of water in which certain organisms live naturally, and it comprises of the fresh water, marine water, estuary, and so on. So today we'll be talking about the marine habitats. Alright, the learning objectives are, at the end of the lesson, you should be able to define marine habitat. You should be able to highlight and explain the zones of this habitat. You should be able to tell the characteristics of this habitat. You should be able to highlight and tell the features of the plants and animals found in this habitat. And you should be able to tell us the kind of fishing found in these habitats. Alright. Let's start from the meaning of marine habitat. This habitat refers to the habitat which contains high salt. High salt means high salinity. These marine habitats include the ocean, the lakes, the shores, and the open seas. Alright, the characteristics of this habitat now. The major one there is high salinity. The saltness of this water is very high, and this is what makes it a marine habitat. The next one is density. This density of marine habitat is also very high, and this gives the chance for the organisms living in this habitat to be floating so well. That's why you see different organisms in these habitats loving to displace, jumping from one location to another. It is because of the density of this water. Another one is pressure. The water pressure increases with the depth. The farther you travel, the higher the pressure. The size. It is believed that this habitat represents the largest of all habitats because it occupies about 70% of the total mass of the earth. So it's telling us that marine habitats occupies almost everywhere in the world. Alright, the next one is current. The currents are produced by the wind, also the tide. The tide also are generated from the change from the rise and fall of the water. We have oxygen concentration. One thing with oxygen here is that the farther you travel down in the water to the water, the less oxygen you have there. So when you are at the surface, you enjoy more oxygen. The next one is temperature. The temperature also decreases with the depth of the water. So there are some region or zones in this marine habitat that is known to be freeze. That is a kind of iced block layer where everything will turn to a frozen layer. And funny enough, some organisms still find their way to live beneath this region in this habitat, and the light penetration also. So because of the nature of this habitat, there is high turbidity. That is, the water transparency is very low because it is very deep, and the bad light from traveling through it. So these are some of the major characteristics of these habitats. Let's move on. So let's look at the major zones of this habitat. One thing from your note, we said that there are two major zones. We have the benthic zone and we have the pelagic zone. So let's look at the pelagic zone. In your notes, there is a diagram I put there showing how these zones vary from one meter to another. So let's start from the first zone of the pelagic. The pelagic naturally represents the open water. That is the open water where you can travel through the water, while the benthic mostly represents the bed layer of the ocean. So the open water is the pelagic now. So from the pelagic we have the first layer called epipelagic. It is the surface area It is the surface area of this habitat. Alright, are we together, class? God, I don't wish him well. I need to then visit flight mode. Ọlọ́mọdé ò cut, ó dà pé tó mo ṣe kẹlẹ́ nǹkan ilé cut. So, we are talking about the epipelagic zone, and I told us that it is the surface layer of the ocean, and something about it is that even this top layer is about 200 meters in height, and which is about 656 feet. It is known to be sunlight zone because it enjoys more light penetration. So most photosynthetic processes will be happening here, followed by the next layer called the mesopelagic zone. This zone is below the epipelagic, and this one extends from that 200 meter to about 1000 meter deep into the water. And this zone is also known as twilight zone because it still enjoys some little light penetration from the epipelagic zone. So the next zone here is called Bethel pelagic zone. This zone is the one below the mesopelagic, and this one is also referred to as midnight zone or dark zone because of the darkness that prevail in this particular zone. And one thing about it is that this one extends from that previous 1000 meter to about 4000 meter down the water, and the only source of visible light here will be produced by some of the animals that are living here. Some animal can generate light, lanternfish and his family. So those lights produced by this kind of organisms will be the only available light in this kind of zone. The next zone is abyssopelagic zone, and this is below the Bethel pelagic, and it is known as abyssal zone because it does not seem to have an end, and it extends from that 4000 meter to about 6000 meter down the ocean. The water temperature here is nearly freezing, and there will be no light at all. Even oxygen here will be nothing. The last stage there is Edapelagic zone, which is below the abyssopelagic zone. And something about this zone is that here it extends from the 6000 meter down to the bottom of the ocean, where life activity can hardly be noticed. So this zone seems to be a kind of lifeless zone, but sometimes researchers do tell us that there are some few and rare organisms that still live in this area. Let's move on. The other zone, I told us we have other zone called benthic, but based on light penetration now we have three zones. Based on light penetration we have three zones. The first zone is called euphotic, and this is the area where light connects to directly, so it has high photosynthetic activity, and plants and other organisms that depend on light mostly are found in this area. Followed by the next layer, dysphotic layer. This dysphotic layer can also be called littoral zone. It's about 200 meters deep. Those organisms that feed on photosynthetic organisms are mostly dominated in this area, and the last zone here is called aphotic zone. This aphotic zone simply represents the zone without light, and life activity seems to be less here. It means that very few living organisms will also be found in this zone. So let's start looking at the kind of organisms that are found in this wonderful habitat. We are looking at the plants that are found in this habitat now. Those plants are seaweed, algae, another type of algae, and plankton. How do they survive? Like the seaweed, they possess something called the holdfast that give them the ability to attach themselves to some materials in the ocean. They have divided leaves that can help them to carry out photosynthetics. They have air bladder that will give them the buoyancy they need to survive. The second plant there, the algae sargassum, that one they possess chlorophyll, and this chlorophyll will aid their photosynthesis, and they have large surface which enhance their floating. Sesavom is another kind of plant like algae in nature. Those one possess thick leaves for conservation of water. The plantain are mostly microscopic in nature, so they also have some kind of microscopic structure that enhance their survival. Let us make some of these plants. Let's see the image of all these plants. So this is wild algae. You can see how it looks like. The sargassum, this is how it looks like. The seagrass, this is how it looks like. So those are the images. Let's quickly meet the animals in this area. We have the barnacles, we have the cartilaginous fish like shark, we have the bony fish like tilapia, we have shrimp, we have crab, we have periwinkle, we have starfish. Something about most of the organisms here is that they have a kind of thick body like shell which give them resistance to the salinity of this habitat. Like the barnacle now, they have mantle that will allow them to hold fast to the materials around the water like rock. They can respirate, they can move, they can feed, and they have shell that will prevent them from desiccation. That is, when too much of salt is too much, this shell will give them protection. Cartilaginous fish, those ones will retain their urine in their body, and this allows them to cope with the salinity, because the difference between the environment and their body is not that wide. When you retain urine in your body, it means that you are saving some salt in your body. So when you have too high concentration areas, you won't be having much problem losing water to your environment. If you understand our knowledge of osmosis back in the days, I told us when we have too isotonic concentration, there will be no movement of molecule from one concentration or from one region to another region. So the tilapia fish there is that those ones, they possess a lot of features like gills, like eye, like their operculum. All these enhance their survival in this habitat. We have shrimp. Those ones have powerful claws that help them to attack and hold themselves to any region so that they won't be carried away by the wave and tide of this habitat. We have crab that can burrow, come down to the sand, burrow into the sand and hide forever. We have periwinkle also. All these organisms, they've developed special features that enhance them to live in this very funny habitat. Let's meet some of the organisms in this marine habitat. We have swordfish, you can see the image, jellyfish, hermit crab, and turtle. Alright, let's quickly look at the last subheading in our notes, which is known as food chain. The food chain in marine habitat, we have two types of food chain here, one with 4 trophic level and the other one with 2 trophic level. Most trophic level here are plankton. The diatom, I told us they are kind of microscopic living organisms. These diatom are fed on in the first example of food chain by zooplankton. Zooplankton are kind of animals too, but they are tiny, but a little bit bigger than the diatom, but they are still microscopic in nature. So they are being fed on by tilapia, and tilapia is being fed on by the fish. The second food chain, you have diatom being fed on by crab, and crab being fed on by the tilapia. So this represents the kind of food chain in this habitat. Because of the length of this video, I wouldn't want to be saying much. When we meet in the class, we can discuss every other things that we need to add to the note. Thank you. See you soon.